Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems. Hey, I'm Tom Gozzi. Welcome to Hot and Cold. Well, it looks to me like we're trying to hook up a heating system. And in fact, we are. We have a Toyotomi water heater that we're going to start to get hooked up today. And through the magic of television, we'll get it done in this show. Oh, man, does it get any better than that? I don't think so. I don't know where that pipe goes. Well, here we are, down in the basement. We're in the opposite end of the basement from the oil tanks. And if we didn't have so much junk around here, we could pan back and forth, but we can't do that. And we've got a Toyotomi water heater. Now what I love, and I thought long and hard about what we should put in here for a heating plant. We have a building that's 1,000 square feet. It's insulated like nobody's business. I had options to get a lot of high-end heating gear in here. And I made a choice back months ago, 6 months ago, and I'm really happy with the choice I made. And what I got was a Toyotomi water heater. This is made just for heating domestic hot water. It's roughly the size of a 2-drawer file cabinet. It fires, it's an instantaneous water heater. So that means that as you're drawing hot water, the burner comes on and heats the water as it comes through. Pretty slick. It inputs 140,000 BTUs an hour. Excuse me, it runs at 88% efficiency and gives us really good performance. It is a direct venting unit. We have the vent here. It's all stainless steel. It's a concentric pipe. It has a cool little insulated sock that goes over the pipe. I like that. I had it up because I'm not done with the flue pipe yet. But it's got a concentric pipe, so the fresh air comes in through here, through this thing that looks like a dryer hose, into what they call an air inlet. The exhaust comes out through this 2 3/4 inch roughly stainless pipe, and goes out through the wall. What we did was we took out a window that was here, blocked it in, and I put some foam over this because the rest of it is spray foam. And so the venting is all set. And the venting, to me, is one of the hardest parts of the deal. And the venting isn't hard. You poke a hole, I think it's 4 3/4 inch hole through a wood wall, and it's zero clearance, so you can just pop right through the wall with the vent. In this case, we went through concrete, and that's done. The rest of it is fairly straightforward. If it was a domestic water heater, we have cold water going in here. We have hot water coming out here. You hook that up to your plumbing, and you're ready to go. A couple other things. There's a pressure relief valve on the side, as all water heaters have to have. The drain down at the bottom, and we have a plug because we plug it in. It's electrical, or it has electric requirements. The oil line goes in here, and we'll put a filter on here and then go through the oil, go to the oil line over to the raw tanks. Inside the unit is really constructed something like a traditional oil-fired boiler, except it's Japanese, and they do things a little bit differently. One thing they did is the oil burner is sort of, instead of being that black thing that hangs off the outside of a boiler, it's sort of taken apart and exploded here. So we have a separate oil pump here, and then we have an ignition coil here, an igniter. This is the blower, and there is a conventional nozzle and igniter electrodes inside here, but it's a little bit different. You can see that. Behind the panel over here is electronics, because you have to have things going in a time sequence. Where we're running water through this and heating it as it goes through, there have to be certain kinds of safeties and things. That's done electronically. very effectively. I've put one of these in probably 6-7 years ago for a friend of mine that had a solar system. And we did two things with it. Obviously, we used it for domestic hot water, but we also used it for backup for his radiant floor system. And it worked very well. And we're going to do something similar here, but we'll talk about that more in a minute. And we've had good results with the unit. The controls are pretty straightforward. We have indicators that tell us whether it's operating, whether the burner's on, and of course a warning if something isn't working right. Power switch on and off, pretty straightforward, and just a thermostat for hot and cold, hot and very hot water. There is no cold setting there. It's hot. Oh, there is cold setting. I missed that. Hot and very cold, hot, very hot. I'm so excited we're going to have hot water in here. We haven't had it since almost the beginning when we started the project. And that's pretty much it. We don't have a lot to do here in terms of the unit itself. And when we get it operating later in the program, we'll look at it actually functioning because the sound level that comes out of this thing is pretty quiet. The case is insulated. The heat exchanger, which is sort of the heart of the unit, is in the second half, the back half here. So there ain't much size to it. It's a very efficient little heat exchanger. Other things we need to do. Whenever you use a fired appliance, you should have a thermal safety cutoff. This is it. It's going to go in this box here, and it's over the combustion area. So if, God forbid, there ever was a fire, it kills power to the unit, stops it from running and making more fire. You can see that is not completely done yet. I need to put this in, and this is just a switch. So we have two wires here that'll interrupt the hot lead. We're going to put a panel over here on the wall. I think this is the panel itself. Isn't that something? We're going to hang that. I'm just waiting for the foam to set up because I foamed this earlier this morning. We're going to hang that, and on that panel, excuse me, will go most of the stuff related to the heating system because there is a little bit more to go with this. But I tell you what, let's do this. Let's take a break. I'll gather those bits together and explain to you how this system will actually go together to get heat upstairs during a Maine cold winter from this little thing. Can you believe it? I'm just amazed. Well, we're back, and through the magic of television, we've actually fast-forwarded through a little bit of time, and we have the unit kind of jerry-rigged, and now we can actually show you it functioning. You can hear it. You can hear the sound it makes. Oh, that's so cool. We don't have it completely hooked up yet because we're still waiting for things like the radiant floor and radiant wall stuff, but I do have the toe space heater, which you saw in last week's show, running. So we want to show you now everything functioning down here. There's a lot of extraneous pipe floating around because I don't want to cut anything too short because it's got to be rerouted somewhere else once we get the final hookup. But let's go back over what we have here. We now have oil coming into the unit here. We have a filter going right in. It's all set. The unit is actually running right now. It's not actually running. The system is running. The unit will fire up in about a minute or two, and we'll alert you to that fact when I hear the whisper, the silent whisper of the Toyotomi water heater. Oh, here it goes. The fan just came on. Can you hear that? I'm going to get close to the unit. And it's actually firing now. Let me get down next to it so you can hear. Ah, the sound of heat. Very quiet unit. You got to love it. And it won't fire for very long because we, excuse me, are not taking a lot of heat out of the unit with that little toe space heater. But what we have is the hot water outlet here. We also have hot water to the faucets now. Oh, it's very nice. We come off of here with a shutoff valve. We've got a lot of shutoff valves because when you put pumps in, you want to be able to isolate them if, God forbid, you ever have to do any service on them. So here we have a little Takeo 006 bronze pump. Comes out of the unit. We've got a check valve here, which only allows water to flow in this direction, to be no backflow. It goes into our plate heat exchanger, which is mounted on the wall here, and there's a shutoff on either side, of course. And then it comes out here and would normally go back to the water heater. And this would be one side. This would be what we would call the potable loop. We would just have potable water running through this stainless steel heat exchanger, which is a lot of layers of plates here with water on one side. And then on the other side of the plate heat exchanger, we would have the radiant heating system, which would be isolated on the opposite side of those plates, which is not hooked up yet. We'll get to that in a second. What we've done in the meantime, just so I could get a lot of the plumbing, rough plumbing out of the way, is we have the potable loop plumbed in. And instead of just returning back over to this side where this red pipe is, we go instead into this white pipe, which goes out to the little toe space heater. This other pipe here is the toe space heater, kick space heater return pipe, which I've jerry-rigged through a compression fitting back into here. So we are running potable water, as I said we were going to do temporarily, out and back. Very simple. Gets a little bit more complex on the other side of the heat exchanger. We would have hot water coming, or hot water or hot antifreeze coming out of here, bigger pump, because we're going to be pumping through more stuff, and the rest of the system goes right here. It's not here yet. It will be next week, maybe. The reason I haven't really plumbed it all in is because it has to tie into manifolds. We've got, let's see, let's count them. We have the kick space heater, which is running. That's one zone. We'll have a zone of radiant floor for the bathroom. That's 2 zones. We have a radiant wall for the living room. That's 3 zones. We have 2 bedrooms, which will be 5 zones of heat in this little dinky house. And we really don't have to zone them all separately, and we may not, but we'll have them all coming back into what a manifold is basically just a bunch of T's that tie together to feed everything in and out. So, excuse me, we'll use manifolds because they are kind of easier to plumb to, but they're not here yet. So we're in no big rush to hook up the rest of this, although I'll probably start that today. And what we're going to do is we have a female connection on this side, so we'll screw in a male adapter, and then we'll put in a pressure gauge. Tells us what the pressure of the system is because we have to pressurize this system. We'll put in a couple of these. These are boiler drains, so we can put fluid into the system through a hose and bring fluid back out of the system as we charge it. And in between the two is a check valve. The check valve has a little arrow on it. Check valve is a one-way director, and it's got a little thing in there. Can you see that? See that little flapper going back and forth? It's all bronze. And if I blow this way, blows right through. If I go this way, nothing happens. So it's a one-way flow device. And we only want heat to flow in one direction. We want it to go out of here, upstairs. And we don't want it to flow when the circulator pumps are not running, so we can use a check valve to stop that from happening. Otherwise, we may have just the buoyancy of the hot water moving fluid through the system when we don't want it to. So check valves are relatively inexpensive and solve that problem. It goes in between these 2 faucets, and you'll see this again when we hook it up. And this will allow us then to charge the system, and you'll see how when we get to that point. We ain't there yet. We don't have to worry about it yet, but it will go here. So that makes that part of the system pretty simple. This device again, the plate heat exchanger, allows us to completely segregate potable water, which is drinking water, from the heating system. So if we want to antifreeze the system, or if we're just having a heating system, remember I was talking about Legionnaires, and we get this biofilm, the bioslime forming on the inside of the pipe. In a heating system, it's possible, if there's fresh water coming in all the time and oxygen and stuff, that we get this biology taking place in there, and it's stuff we don't necessarily want to be ingesting. So if we segregate the 2, we're in pretty good shape. Now what we're doing is the only place we're now going to have potable water once we do the changeover is going out into here, into the plate, and back in again. So very contained, very hot, and we don't have great vast surface areas to grow any kind of bacteria. So that's a real positive thing for keeping that from being a health issue. And this is the way you should use a water heater to do heating. And a lot of people, again, use a water heater, whether it's a tank water heater or a nice unit like this Toyotomi, as a heating device, where it is really just a water heater. So we need to segregate those 2 areas. I can't emphasize that enough. It really doesn't meet code, and it's not healthy. So don't just put a water heater in and call it good, unless it's completely dedicated. Now, the plot thickens, because I've had this running for about a week and a half or so. And when I leave here, I've got everything kind of jerry-rigged, right? When I leave here, I'm not real crazy about leaving the city water pressure on this unit the way it's presently set up, because we're running relatively warm temperatures and we're running relatively high pressure. So, and I've got temporary fittings here. Anything could leak and start dribbling. So what I do when I leave here is I shut off the water feed to this. I've got an expansion tank here which gives us some reserve capacity in the system. And once I shut off the water feed, now I'm not necessarily using hot water or anything because the water feed is shut off. This functions very much just like a boiler. So, am I making that clear? I think so. And it renders me fail-safe. Now, if I sprang a leak and I wasn't here, what's going to happen? The system isn't going to run. Once it loses the pressure the water tank holds, the system will stop running. The circulator pump will still run. I'll burn out the circulator pump. But I won't have a deluge of water coming into the house. So I like that fail-safe part of the system. Unit's running again, nice and quiet. I tell you what, being as we want to be quiet for just a moment and listen to the unit, let's take a quick break. When we come back, we still have a couple more plumbing things. A lot of plumbing here. I love to plumb, though, don't you? Well, we're back. And just a few more things I want to show you about heating system stuff. Now, remember earlier in the show, I showed you the thermal cutoff. The thermal cutoff is now installed. We have the power coming from the emergency switch up at the top of the stairs, comes in here, goes in the thermal cutoff. This is just a big switch. If there was ever a fire, this melts off, kills the power to the unit. The power to the unit goes through here, through this nice conduit, thin wall conduit. And I love working with this stuff. It's real easy to bend. I have my bender. I took my bender back to the shop. I can't show you the bender. But if you go to a place like Home Depot and take a look at conduit benders are right there. And they're just big bendy, twisty things that are curved. And this fits right into a form. It's great fun to do. And it's a little challenging. You have to think about it a little bit. But it's nice for protecting wire, especially in a industrial situation. This isn't an industrial situation, but it's an area where there could be wear and tear, stuff bangs into it, and by code it does need to be in conduit or in flexible sheathing like this. So we've got it in conduit. So we come down to here, and I've got an on and off switch right here, which is just an emergency service switch. We don't really need it, but I like it because we then go another piece of conduit down to a duplex or fourplex box here. Now you remember the Toyotomi has a plug. So now I can unplug the unit and shut it off right here if I'm servicing it. I don't need the switch for that because I could just unplug. But I do need the switch to shut off this. What is this, you say? This is a pump relay. And the pump relay makes the circulator pump go on and off. This is the interface between the thermostat, which is upstairs, which is 24 volt, and this will be the 24 volt low voltage wiring, and the 110 volts that runs the circulator pump. And it has indicators on the side here. You can't see because your camera's on the wrong side, but there's two little indicator lights, and that comes on whenever the thermostat calls for heat. And if I want to shut everything off, I just flip that switch, and everything goes off. I turn it back on, everything comes back on. So that gives me the opportunity to easily service stuff. I don't have to go back to fuse box and find a circuit breaker and waste a lot of time. And when you're doing service on a unit, you have to be able to either do that, unplug it, turn it on or off, or do it here. Switch is much more convenient. Plus, in doing any service on circulators, everything is right here. So we'll also interface any other control hardware that goes on the manifolds for those zones that are going to be running for the radiant floor and stuff. And that'll all be controlled through here. And you'll see that when it happens on the show. So the 24 volt is very easy to do. It's low voltage circuitry, so you don't get electric shocks. We come then out of the pump relay box with the sheathing, the flexible sheathing. And you can see here, just to keep it simple, I came from this box into here. So this has got 110 volts just running through into here to power this. And then this one goes to here. We will wire one up to this pump when the time comes to get that running. These two pumps will run simultaneously. They'll always come on and run together because we need to bring heat into the heat exchanger, And then, of course, we need to bring heat out of the heat exchanger. Right now, of course, we're not using the heat exchanger, so one pump does everything. When I started this system up, there's another issue that you have to deal with when you're designing these kind of systems, and that is how big's the pump got to be. You can see this pump is dinky compared to this pump, and I've got two bronze pumps here. One of the things you can do when you, on the potable side, the drinking water side, everything has to be bronze, copper, stainless steel, non-corrosive materials. If you put a cast iron pump, which is a standard heating system pump, on the potable water side, it's going to rust up, your water's going to get rusty, you're going to get sludge in your pipes, all kinds of nasty things happen. So we have a bronze pump here. I put a bronze pump on the other side of the system just because of a redundancy where I'm using PEX tubing. I want it all to be, that this whole other side of the loop is also going to be all non-corrosive materials. The reason people don't use bronze pumps regularly on heating systems is they cost a lot more money. This pump here was about $200, where a standard cast iron pump the same size would probably be about $70. So there's a significant difference in the cost of the pump because the hardware is all bronze, but it will not corrode. And I've had experience with plastic tubing systems where we've had oxygen migrate through the wall of the tube, and that can become a corrosion issue. And I can show you here, we have tubing. This is domestic hot water tubing, and I don't have a piece. Wait a minute, let me go. Oh, I do have a piece. As a matter of fact, it's right behind the cameraman. I got so much stuff around. You noticed everything spread around because I want everything right at my fingertips. Now, I can show you the difference here, and this is a discrete difference. This is a straight-ahead PEX tube. There's no what they call oxygen migration barrier. This tubing is just cross-linked polyethylene tubing. It's used for potable water only. This also is straight-ahead PEX tubing. You can see, though, the difference is it's red all the way through. It's a homogeneous color, and the reason for that is red pipe is heat or hot water. Blue pipe, you can see over here, is cold water. So we color code the plumbing in the basement, which is pretty cool. This, let me put that, well, I'm going to hold them all. What the heck? This is heat tubing. And the difference is, you can see it's white like this one, or ivory, whatever you want to call it. But then there's a little film of plastic on the outside, and it's kind of shiny there if I get the dust off it, compared to this one. See that? That's kind of dull. This is kind of shiny. This has an oxygen migration barrier. Oxygen migration barrier stops air. Believe it or not, oxygen can permeate the wall of this tube, which is, what, 1/16 of an inch thick. Oxygen will get into the heating system. Now, it's no big deal if oxygen gets into the potable water because potable water has oxygen in it anyway. But if you get it into your heating system and you have a steel pump or a cast iron pump or a steel or cast iron boiler, that oxygen is going to cause rust. And the rust is going to make sludge, and you're going to have problems with the heating system. So just to keep it real simple, I'm going to use everything on the heating side that is non-corrosive material. So it doesn't matter if I use oxygen barrier or non-oxygen barrier or red or white or pink or yellow, although we will try to color code it, just for your viewing edification. While we have a few moments left, have we looked at the thermostat yet? We have looked. Oh, we have. I don't have to do that then. So what do we do for the rest of the show? A couple more plumbing things. My latest invention. You ready for this? You thought you were going to get away without it, but no. When we do all this stuff on the heating system side, oxygen gets into the water. We have to remove oxygen from the system. When you fill the system up initially, there's oxygen in the water. You have to get it out. And it will separate. As the water gets hot, the oxygen wants to bubble out of solution and be segregated out of the system. And look at what I made. This is an oxygen removal device of my own design. I've actually copied another company's design. And what it is kind of unique. I went up to the store and I bought myself a copper mesh scourer. And it's copper, as you can see, and it's mesh, and you can kind of see through it. And if you I don't know if you can see through that. You can see a little bit of daylight through there. At the bottom of this big 1-inch T, well, what I've done is I've taken this scourer and I've done this to it. I rolled it like this. This is a trade secret. And I've inserted it into this pipe going down into the bottom of the T. Now, as the heated water passes through, it intersects with the bottom edge here, and all this little extended surface we have tends to make the oxygen come out of solution and bubble up to the top, comes up to the top here where there's an air space, and what we have on top is an air vent. The air vent has a little float inside it, and it allows air to exit the system. So we can have it open so it's on automatic, or we can do it manually. This device is necessary for removing oxygen from heating systems. You can buy these pre-made, but they cost a lot of money. I've made several variations on the theme, oh gosh, over about 10 or 15 years, and we're going to put one in here and we'll see. We will report to you how it works. I've never done one with the Quickie copper mesh scourer. So the Quickie air removal device, you will get to see installed here in another week or two, and that'll just be right in line with all this other stuff that makes the heating system work right. Anyway, so here we are. We got the Toyotomi heating the house, and it's not running very much. It's just sipping wisps of heat and keeping the house anywhere we want it to be. We keep it at 52 just to keep us above freezing, and that's fine. When I get here, we turn it up, so we're not going to use a lot of oil. We're not going to use a lot of oil anyway. 88% efficiency. I love this thing. This is one of the coolest devices I've ever seen. You see stuff, if you have any questions on this stuff, give us a call. You'll see we're at the end of the show on the radio on Saturday morning. Till then, keep warm. Make sure your heating system's working right. And you should have had it serviced in the springtime when the people aren't busy, not now when it's really cold out. Take care. Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems.